Hi, my name is Sharath and this is CSC 519 DevOps final presentation. My team consists of Aparna, Shreya and Keshav. So this is a quick recap of all the milestones we've done throughout the course. So to provision iTrust, we needed a few dependencies, namely Tomcat, MySQL, Java and Maven. Correspondingly, for checkbox, the prerequisites were Nginx, Node and MongoDB. This is the picture of the overall pipeline for deploying iTrust. For milestone 1, we used an Ansible server to pull the code from a Git repository and build the project in another VM. For checkbox, we used Ansible to provision it with its dependencies and modify the code to deploy the application successfully. Milestone 2 was just an extension of milestone 1. In M2, iTrust required a fuzzer which randomly introduced changes to the source code, which when committed would trigger a build on Jenkins. The build generated test reports and code coverage reports, which was utilized to identify useless test cases over the course of 100 builds. For Checkbox IO, in addition to the building on Jenkins, we added an analysis component which calculated certain code metrics and influenced the build result accordingly. In milestone 3, we deployed both Checkbox IO and iTrust onto production environment. As it can be seen from the pipeline, a successful Jenkins build would trigger an Ansible playbook to deploy iTrust onto the production environment. The rolling update ensured that 4 instances were operational while one was being upgraded. For Checkbox IO, we made multiple infrastructure upgrades, which included a load balancer, a canary server, and Redis feature flags. The load balancer routed a fixed percentage of traffic to the canary server, which was aborted if any alert was raised. Coming to the special milestone, we'd like to introduce the Ultra Monkey, which is run on the Slack platform. The primary purpose of the monkey is to provide high availability and load balancing. It does so by detecting instance failures through lack of heartbeat messages. It continues to monitor the load on the remaining production environments. Should the load exceed a set threshold, the monkey automatically provisions a new production environment, ensuring appropriate load distribution is achieved. Here we have a diagram depicting the architecture of the bot. The monkey replicates the master Redis data store, which is on the proxy server, to all the operational slaves. For purpose of this demo, the load balancer has been configured to delegate service requests to production environments randomly. Now we'll move on to the demo. This is our SlackBot. Starting off, let's be polite and say hi to the monkey. The monkey can spin up instances on command, so we type spin and it provisions a new AWS EC2 instance and deploys Checkbox IO application on it. An instance is up now, so you just pause to see it on the screen. We've taken the liberty to create a few more instances to save time, so that you can see on the Slack channel now. And so the load balancer evaluates the load on each of the servers, and if it is above a certain threshold, the error message is displayed on Slack and a new instance is provisioned. So here you can see that the load is above the threshold, and you can see that it's spinning up a new production environment. So now on the Amazon EC2 console, we see that there's a new production environment. So this is done by creating new requests on the proxy server to increase the load. So now let's see how the bot responds when the server crashes without a load increase. So this crash is simulated by manually terminating the AWS instance. So just going to do that right now. So it'll just pause for a minute since it takes time for the terminating to come through. As you can see, the monkey generates an error message on Slack. Thank you for watching.